Right, let's back up a bit and go back and talk about the third method of reading data in from a file, which is to go through the file line by line and treat each line separately. So we'll start off talking about this by going back to this file xy.csv.txt. So, and I'm going to delete this header line for the purposes of this example. Just keeps it a bit simpler. And we'll go back to the read file script, okay, and save it as a different script, read file by line, and let's change the header information, so a script that reads from a file line by line. Alright, so all this stuff is good. We still want to open the file and we still want to trap if it couldn't be opened, so all that's still fine. And eventually we will come back and plot the data, but I'll just comment it out for now. We still want to close the file, and the bit we want to do differently is when we're reading data in from the file. So I'm going to delete this chunk here. Alright, well I'll just delete this one. Say read the data line by line. Right, so the way to do this is you use a while loop, and you can say while we're not at the end of the file. So what this condition does, FEOF, if you're at the end of the file, that would be true. If you're not at the end of the file, then that condition is true. So we go into this loop. So in here we can get a line from the file. So let's call that variable line, and the function for this is called fgetL, and you give it the file handle. So now that has returned one of the lines from the data file. So if I run this now, just make sure it's not going to try and do anything. Yep. If I run this now, it should read each line of the file and display it back to me. Okay, so I can check if it's reading the line in properly. So this is something that I do all the time, is step by step in my program, I might write something out so I can check that it's doing what I think it's doing. So in this case it read the line with that function fgetL, and then it displayed it. Okay, of course I don't want this to be the end of this program, but it helps me to check if it's doing what I want. So what I want to do now is, because I'm going line by line, I need to take the line, so the first line it reads is 2,1.69, and somehow I need to turn that into the numbers for my arrays x and y. Right, so MATLAB has a nice function called strutoc, which you can split up a string into different variables with. So I'll show you how it works. On this side we have an array made up of two variables called temp_x and temp_y, and on this side we call this function strutoc. The first thing it wants is a string to operate on, so we've called that string line, so put line there. And the second thing it wants is a delimiter, which tells it how to split the string up. So I want to split up this string, 2,1.69 say, split it up based on a comma. Alright? And let's write out the two things to see what's happening. Okay, so let's run this. Command window. Right, so look at the first thing it did. It split up 2,1.69, so now temp_x equals 2 and temp_y is 1.69. And I can now exploit the fact that I've got those two things, temp_x and temp_y, to build my array. Okay, so I'm going to have two arrays, just define them as empty arrays to start with here. And then I want to extend array x with temp_x, and temp_y has a comma at the beginning, so what I want to do first is strip out that comma. So I do that like this. That says make temp y equal whatever it is, but start at the second position and carry on till the end. So that will strip off the first character, which in this case is a comma. And then I can put that into array y. Now so far you think that that's going to work, but if we carry on, and I mean we can delete this bit now because we've already built our arrays x and y. If we carry on and try and plot this, let's make it red dots. So we might expect this to work, but this won't work, I think. Okay, so what it's saying here is plot invalid argument, and what's happened is that temp x and temp y are actually strings because we built these variables by splitting up a string. So when you split up this string, we get two strings back. So all we need to do to fix this is convert these values to numbers using str to num. Okay, so now our files of x and y are both numbers, and now it will have plotted the data that we expected. Now, that wasn't so useful perhaps, was it? Because it was much easier to read this file using the other two methods, using fscanf or using textscan. Okay? And this is what I said at the beginning of this week's screencasts, is that you often have to decide what the best method to use is based on what you want to be able to do. So if you came across this problem where you were reading this data file xy.csv.txt, you wouldn't do it this way. I just showed you this just to prove that it could be done. But let's dream up an example where the best thing to do is to go line by line. Okay, so let's look at say this file, test data. So reading a file line by line comes into its own when you want to do something different depending on what is in the line of the data file, right? And this isn't as wacky as it sounds. There are lots of examples in real physics situations where you need to parse a file and you need to do something different based on whatever happens, whatever is given on that current line. So I've made up this example to keep it simple so that we can do it in minutes. So what I've got here is a file, and the first thing on the line is a letter A or B, and if the letter is an A, then the next thing is an operator, plus or minus, and if the letter is a B, then the next thing after that comma is two numbers. So what I want to be able to do is read this file in, and if the line starts with an A, I decide I'm going to add the numbers on the line that start with a B. So I'm going to do something completely different depending on whether my line starts with an A or starts with a B. So let's go back to read file line by line and change this to a different script. Read test data. Okay, let's go and change the header information. Alright, so this is not the file we want to open. We want to open the file called test data. I still want that. I don't want this anymore. I still want to go line by line. I still want to get a line from the file, but let's delete this, and we're not going to plot the numbers. It's not about that anymore. And let's display the line here just as a test. So let's run this now. Read test data. Okay, so it's reading the file correctly. That's the first thing. Now I want to extract the letter from the first comma. So let's do it like this. So we'll do the same thing with str.toc, splitting on a comma, but we'll call the first thing comes out type, so that'll either be an A or a B, and we'll call the rest of it the rest. struct line based on a comma. And now let's just display the type and make sure this is working. So run the program. Yes, it worked. It just got A or B. So now we can switch on type. And we've got two cases. The case when it's A, do something. The case when it's B, do something else, end. So if it's case A, then I want to look at the second bit. So rest is, in this case, will contain on the first line of the when it runs through and reads the first line, it'll have read the line A comma plus. So type will contain A, and rest will contain comma plus. So, but I don't know whether it's a plus or a minus. So I need to strip off. So let's do rest equals rest to end. That strips off the comma. Alright, and then operator equals rest. Alright, that's good enough. So the operator is now whatever was contained in rest. And if we want to check, we can display it and run that and see what happens. Okay, so now it only displayed anything when it was case A, and there are two lines in the data file when it's case A. First one is a plus, second one's a minus. So that's good. Right. If we're on case B, that means we're on a line where we've got some numbers, and these are the numbers that we're going to do something with. So let's say we've got a comma and two numbers, so let's do the same thing to start with, strip off the first comma. Now let's do x, y equals struct rest and a comma. Okay, so this now splits up the string rest, which in the first time through, when it gets to B, it'll be comma 5, comma 4. So we remove the first comma on this line, so now it's 5, comma 4. Now we say split the 5, comma 4 by a comma into x and y. So now x should be 5 and y should be 4. And we can check by writing them out if we're not sure. Alright, so x was 5 and y is comma 4. So we need to do two things, don't we? We need to say, first of all, we need to convert the string x to a number, and then we need to split off the comma from y and turn that into a number as well. And now we can actually do the calculation. So now we could say z equals x. Oh, hang on. We need to switch on the operator, don't we? So we need to know whether it's a plus or a minus. So switch op case plus z equals x plus y, case minus z equals x minus y, end. Alright, so now we've got z, and now we've got z, and we also know op, so we can write out to the screen, we can write out the operator, we can write out the number, the operator again, the number, equals, and the number. So here we want op, the first thing, x, op, y, z. And then let's put a new line. Alright, now it should do what we wanted. Okay, so this time 5 plus 4 is 9, 1 minus 2 is minus 1. So this is quite a convoluted example, but it shows you a good use for going line by line through a file, because you might want to do something different depending on what is contained on that line of the input file.